Good evening, everyone. This is January 2019, paper 1C. In this session, I'll discuss question 9 and 10. So, in question 9, some metals can be obtained by heating their oxides with carbon. The diagram shows this is a blast furnace used to produce iron. What we call the ore of the iron is called hematite. Explain the role of hot air in the furnace. So, what is the purpose of the hot air? The hot air will react with hot air basically contain oxygen, and oxygen will react with carbon to produce carbon dioxide, which increases the temperature of the furnace, and produce carbon monoxide, which is a reducing agent. So hot air provides oxygen, which react with coke to produce carbon dioxide, result in increase in which result in increase of temperature in the furnace. So when we want to balancing always start with oxygen followed by hydrogen and the last other element. So we have 3 oxygen and 2. So if I try to put 3 here, so now it makes 6 oxygen. So I should put 2, so oxygen is balanced. What about carbon? 3 carbon, so I put 3, carbon is also balanced. Iron, 4 hydrogen iron, so I put 4, iron is also balanced. Limestone is one of the raw material that is added to the blast furnace. Explain how limestone remove silicon 4 oxide from a furnace. So limestone decompose due to heat and form calcium oxide. Calcium oxide is basic oxide which react with acidic silicon 4 oxide form slag, and the slag is removed from the furnace. State why aluminium cannot be produced by heating with its oxide. So aluminium is more reactive than carbon. That's why we cannot use we cannot react the oxide of aluminium with carbon. Describe how aluminium is extracted and purified from aluminium oxide. So we use the method or the technique which we use, that is called electrolysis. So electrolysis of molten aluminium oxide is done by using carbon electrodes, and cryolite is added to lower the melting point. and aluminum ions discharge at cathode to form aluminum metal. Question 10. A student does a titration to find the concentration of a solution of aqueous ammonia. He uses this method. He pipette out 25 cm cube of a sample. He adds few drops of indicator, add sulfuric acid from a burette until indicators show a color change. State what the student should do while adding the acid to make sure that the indicator color change uh, permanently. So he should swirl the mixture or content in the flask. The table shows the volume of acid which is added in the concordant result. Concordant to 0.2 means zero point 0.2 more or zero point 0.2 less. That will be the concordant. So 2.43, 23.40, 23 point. When we check, because what we have to do, we have to check which one is concordant to zero point 0.2, means 0.2 more or 0.2 less. So if I select 23.4, that is not concordant to with respect to other numbers. So because it is more than 0.2, so these are within the range. 23.15, 22.95, 23.10, these are concordant, so these are the three. So we'll calculate the mean by only taking the concordant result. So add them and divide it by 3. So when we add and divide by 3, it will be 23.07. Calculate the amount of moles of sulfuric acid in 22.7 cm cube of sulfuric acid. So we have the concentration and we have the volume which we use. So moles equal concentration into volume. Zero 0.08, the volume is 22.7 and divide by 1000. So we'll get the moles of sulfuric acid. Which will come out as 0.0018. Then moles of ammonia in the next part, because the ratio is 1:2, so ammonia moles will be twice of this number. So we'll use a ratio as a ratio between sulfuric acid H2SO4 and ammonia. From the equation, it is 1:2. So if it is 0.0018, so this will be x, so 0.0036. We have the moles now and the volume of ammonia which we were using for the experiment, 25. So we will get the concentration. Concentration is moles by volume. So 0.0036 divided by 25 and divided by 1000, so that we can get in dm cube. So this gives the concentration as 0.14 moles per decimeter cube. That is the concentration of ammonia solution. Describe how would you use this method of crystallization to obtain pure and dry sample of ammonium sulfate from dilute solution of ammonium sulfate. So what we will do, we will heat and concentrate the solution. because method of crystallization, till point of crystallization, then we will cool down the solution, then we will filter and dry the crystals with tissue paper, or you can use a filter paper. So this was the last question from January 2019, paper 1C.